Here's a piece of Python code, and here is that same code but written in TypeScript. Looks pretty similar, doesn't it? Well, TypeScript and Python are both widely used, versatile and powerful, but actually they couldn't be more different. Today I'm going to explore what you need to know about TypeScript as a Pythonista. I'm going to look at the syntax, the ecosystems, and the overall philosophy of these two languages and how these intertwine. Yes, that's a fancy word. It's time we become a bit more intellectual over here. By the end, you'll know a lot more about TypeScript, when to choose it over Python, and how it compares to languages like Rust and Go. This video is sponsored by Localize. More about that later. I'm going to start with a story. My first encounter with TypeScript was in 2016, when I started a company to build a website platform for musicians. The idea was to create some sort of mix of Wix or Squarespace with Patreon, where fans could support musicians with monthly payments. Now, we made a ton of technical mistakes while building that product. I still have some of the code and, well, it's pretty cringe-worthy. Actually, if you happen to follow my software architecture course, then I actually show some of the code and the questionable architectural decisions that I made at the time. But at least one thing we absolutely got right was choosing TypeScript over plain JavaScript for both the front end and the back end. TypeScript's static typing made managing our code so much easier, especially as the project got more complex. And that experience is also why I'm always pushing for type hints in Python. Types save you so much hassle in the long run. Now, Python was launched in 1991 by Guido van Rossum. It was designed to be simple and readable, almost like English. And this is also one of the reasons that Python became so popular. JavaScript and TypeScript as well has a very different story. JavaScript was thrown together in just 10 days back in 1995 to add quick scripts to websites like form validation. Nobody expected it to take over the world. So now it powers websites, servers, thanks to Node.js, and even desktop apps like VS Code. Early JavaScript was a total mess. No real classes, no modules, endless browser compatibility headaches, and by the 2010s it was clear that JavaScript wasn't scaling well for larger projects. And that's where TypeScript comes in. It was launched in 2012 by Microsoft with static typing and much better tooling than JavaScript. And with the release of VS Code in 2015, TypeScript became the go-to choice for many developers, including me. If you use the Python, coding in TypeScript can feel a bit strange. For example, Python uses indentation for scope, while TypeScript uses braces and semicolons. Actually, if you watch some of my early videos, you'll even catch me mistakenly adding semicolons to Python code. The horror! Now, when comparing TypeScript and Python, a really important thing we need to cover is typing. JavaScript is dynamically typed, and while TypeScript adds static typing, it still compiles down to JavaScript, which remains dynamically typed at runtime. Being dynamically typed means you don't have to specify a variable's type when declaring it. The type is determined at runtime based on the value that's assigned to the variable. Here's a TypeScript example that illustrates this. So we have a variable that I assign the value 42 to, and then it's of type number, but then later I can just assign it a string. And now it's of type string. To show you that this actually works, let's add some good old-fashioned console logs to the code. Like so. And then when I use npx to actually run this code, then you see that it actually first prints the number and then it prints the string. Note that I'm using the any type here, and that's basically to indicate to TypeScript that it should not do static type checking. If I do this, then actually you see we already get a problem here in the IDE, but now when I try to run this again, you see that we actually get an error. It doesn't compile to JavaScript anymore because TypeScript found a type error. Here I have a Python version of this code. So again, I have the variable, I set it to 42, and then I set it to a string. Let me just print the variable to show you this. And then when I run this, you see that it simply prints this without any issue. JavaScript, and therefore TypeScript, is also pretty loose in terms of conversion. It always tries to come up with at least a reasonable value. Here I have again my piece of TypeScript code. What you can do in TypeScript is, let me type the variable name again, and then I'm going to assign hello plus 5 to it. And then a semicolon. Oh gosh, I hate these semicolons. And then I'm simply going to console log that variable again. So when I run this, you see that this actually runs without any issue whatsoever. In Python, that doesn't work. So if you try to do this in Python, this is actually going to raise a type error because Python is actually strongly typed. You can also see that happening when I run this. If you want to fix this in Python, then, well, you basically have to turn this into a string, like so. And now when you run this, there is no problem whatsoever. Now, the fact that JavaScript tries to come up with a reasonable value for something also means that sometimes conversions are a bit weird. Like here, for example, we can do true plus true, and then we can compare that with 2, and that's going to return true. And there's also the triple equal sign, which I don't even want to get into. It's a bit of a mess how that all works. And you also have this example that also evaluates true. And there are more of these cases where it's kind of unexpected why something is truthy or falsy, which can lead to some pretty frustrating bugs. Here's what happens when I run this code. Python has type hints that provide optional static typing. Adding typing in Python has zero effect on how your code actually runs. Types are purely there as a helpful tool during development. They're ignored at runtime. Now, there are, of course, type checkers like MyPy, but they're optional. I personally find I don't really need them since type checking is most useful to me in the IDE. This is very different from TypeScript, which has static typing by default, and that enables errors to be caught during compile time. So for example, if we go back to this code and I change the type of this variable to a number, now you see that we get an issue here, and then when I try to run this, like so, you see we get a type error. It's not a runtime error, it's actually something that happens before the code is actually run. That can be an advantage because if your code actually doesn't run because of an error, well, then you need to fix the issue. Whereas in Python, you can get away with hiding the error, just ignoring it, or it just happening in some particular cases where you pass around the wrong value. So in TypeScript, that doesn't happen that much. What's interesting, though, is that the difference in type systems between Python and TypeScript makes sense if you look at their use cases. TypeScript's and JavaScript's dynamic typing makes it super flexible for handling all kinds of data on the web, while Python's dynamic but strong typing, combined with optional type hints, focuses on readability and reliability. This is especially handy in fields like data science and machine learning, where understanding and managing data types is absolutely critical. Speaking of handling data effectively, there's another challenge that many developers face, which is localization. If you've ever had to translate your app or website or machine learning tool, you know it can be a total headache. That's where today's sponsor, Localize, comes in. Localize automates all your translation and localization projects. They have a really simple API. Let me show you how it works. Here's a basic Streamlit data dashboard that displays Uber pickup. When you take a look at the code, you see that this dashboard uses Localize to provide the translated text in the interface. I'm using the Python SDK here that Localize provides you with. Setting up the connection with Localize is really easy. You just need to create an API key in the interface and then create a client in your app. Now I simply supply the API key that I take from the environment, and I also have a project ID. And then I have a couple of helper methods, functions to quickly get a translation from a key. So once you have this basic boilerplate code, it's actually really easy now to get translations in the interface. Now, as you can see in the dashboard, one line of text hasn't been translated yet. So let's add this. Here I have the localize interface, and I'm going to define a new key called NB pickups hour. And I'm going to give it a default English translation. In my app, I don't need to do anything. I can simply restart the app. And as you can see, the new translation is now right here. Now it's really easy. I can now also add other translations, like for example, the Dutch translation. Now AI is directly integrated. I can simply click that, save that, and now I have my Dutch translation ready to go. Switching to another language in my dashboard is now really easy. I simply replace the value of this language constant by Dutch in this case. And now I have a translated dashboard. This is all being handled by Localize. So if you're dealing with complex localization, Localize makes things way easier. With AI-powered translations, you get results in seconds, literally 10 times faster than doing it manually. And it's not just fast. Localize AI keeps things accurate with glossaries and context-aware translation. So your content actually makes sense in every language. Faster, better translations mean you can launch in new markets without the usual headaches. On top of that, you can assign, review, and approve translations in one place. No more messy spreadsheets or endless back and forth, just a streamlined workflow. And when it comes to tracking progress, Localize gives you real insights like how much of your content is AI versus human translated, and predictions on when translations will be ready so you can launch on schedule. Try Localize for your project today using the link in the description. Now, back to the video. Another important difference between Python and TypeScript to me is that in certain aspects you notice that TypeScript has been built from the ground up to properly work with types, whereas in Python they were added kind of later. Although you could argue TypeScript is a kind of later version of JavaScript. Now, TypeScript can infer types without requiring explicit annotations in many cases, making your code both concise and safe. It allows for complex type combinations, which enables you to define very precise types using union and intersection types, for example. Now, Python, of course, also has this up to a certain level. Union types in Python and TypeScript work pretty much in the same way. You can clearly see that in this example where I have a function that prints some input. Input can be a string or an int, so that's a union type. And then I'm using isInstance to decide what to do. In terms of design, this is not great. Let's be honest, but I just wanted to show the possibility of having a union type in Python. If I didn't put the unit type, I would probably use something like single dispatch from the functools package. Now in TypeScript, this looks exactly the same. So here also we have a string or a number union type, and then I print that input. And in TypeScript, I'm using typeof to determine whether it's a string or whether it's a number. And by the way, this is not the only way to do it in TypeScript. You can also use instance of, but since we're actually looking at a type, I find typeof to make more sense in this particular case. Intersection types are something that Python is not that good at. So here I have an example in TypeScript again, where I define a few types like has name and has age. And then I have a type person that's an intersection between these two types. So person both has a name and an age. So here I have a person who's aged 35, which is not really my age, by the way. Guess, how old do you think I am? If you know, post it in the comments. Anyway, and then I do console log of the name and the age of the person. And this is what happens when I run this code. Now in Python, you can't do that, but there are some workarounds. So here I'm using a protocol, for example, to do exactly the same thing. So I have a class hasName, which is a protocol that uses Python's duck typing, and I have hasAge, and then I have a sort of intersection type, which is a person class, which is then a subclass of hasName and hasAge. And that kind of works. However, in my opinion, this is pretty ugly. It reeks of multiple inheritance and mixins, and I'm not really a big fan of that. At least when you're doing it with types, then you're staying clearly away from classes and inheritance and instances. So I much prefer that route. And by the way, if you're wondering if there is some other alternative for protocols in TypeScript, then actually there is. TypeScript has something called an interface, which is like a specification of the structure of an instance of something. So in this case, we have an interface vehicle, which has a speed and has a drive method. And then I can have a class car that implements the vehicle interface. This is kind of similar to how it works in C# and I believe Java as well. So there you simply have your constructor, which has a speed, and then we have drive, which then does something. And then I can create a vehicle, my car, and then I can have some other random object and then actually assign that to another car, which is of type vehicle. And that actually works because this random object matches the interface. So in essence, both interfaces and protocols, they define a sort of contract that an object should adhere to. But in Python, protocols are actually classes, and in TypeScript, an interface is really a different syntactical element. So that's the main difference. Talking about types, another thing I don't really like about Python's typing system is the callable type, which I find quite clunky and verbose. Now I kind of understand where it's coming from because, I mean, if you add these things later to a language, you sort of have to make sure that it fits with the rest of the syntax. So I can definitely understand why they chose that particular syntax for the callable type, but I still don't really like it. You can see the difference in readability right here. So this is a TypeScript type definition of a function, something that takes a name and then returns a string as a result. And then you could have a function that's of that type that then gets a name and then returns something, right? I find this really easy to read. It's pretty clear what the arguments are. We see what the return type is. I love it. I really like this a lot. In Python, though, it's going to be different. Here we have a type greet, which is a callable, and there you have these square brackets, and then you have another pair of square brackets, and that's where you define the arguments. And then you have the return type. Now you already see some problems with this in that I find it kind of hard to distinguish between the arguments and the return type, even though these are between square brackets. It's easy to overlook, especially if, for example, there is no return type. Then, well, you probably have to define none here. What happens, can I just leave this out? Now it's basically gone. And then let's say if I add more types here, then now it's pretty hard to figure out what is the argument and what is the return type, right? Or you might miswrite it, for example, and then accidentally put it behind the bracket, whereas actually you intended it to put it inside the bracket because it was an argument and not a return type. So it's pretty frustrating. Another limitation of this way of defining callables in Python is that you can't specify the name. I really like this type of specification where I can actually specify what the argument is going to be, because then as part of my type definition, it provides information. I know that the greet function expects a name. Well, and then I can probably surmise that it's going to do something with that name, like send a greeting to it or something. In the Python version of that, this is simply not possible. Of course, you can not use the callable type in this way. You could also define a class and then define the call dunder attribute, and then you can actually specify the arguments there. But that's also pretty verbose and honestly kind of hard to read. So there's not really an ideal solution in Python. It would be nice if Python adopted a syntax that is actually pretty close to this, but I'm not really sure that's ever going to happen. Overall, though, my impression is that TypeScript's typing system goes beyond Python's type-ins because it's a bit more expressive, flexible, and it's better integrated into the development workflow. Features like unit types, advanced generics, a more intuitive function type syntax, in my opinion, make TypeScript a better choice for teams and large-scale projects, where type safety and maintainability are really important. A few words about the ecosystem. Running Python scripts is actually pretty easy. You install Python, you can run simple Python scripts right away. If you need to install dependencies, there's Python's default package manager, pip, that supports Python's extensive libraries like NumPy, Pandas, and FastAPI. As of recording this video, you can see on PyPy that we have over 600,000 projects that are available, which is huge. The issue, though, is that there's no good native Python project management solution. I mean, there are good third-party options available, such as Poetry and UV, which is my current favorite. These allow you to create virtual environments, manage project-specific dependencies, and even publish Python packages on PyPI. TypeScript is different. It's built on JavaScript ecosystem. There's a package manager called npm, which is part of Node. We don't have an exact number of packages on npm. At least I couldn't find it. If you know where to find it, post it in the comments. But if you look on the website of npm, you see that they boast having over 2 million packages, which is way more than Python. But there's a reason for that. I'll talk about that in a minute. To run JavaScript or TypeScript, you need a browser or Node.js. And there you're going to quickly notice a difference between Python. TypeScript has way less batteries included than Python, so you quickly need external dependencies. It's not really a problem, but that is actually the case. And that's probably also why there are so many different npm packages and way more than Python. And things can actually get pretty complicated. You're going to need a build tool that compiles TypeScript into JavaScript. You work with pretty complex frameworks like Next.js, React. There's also HTML, CSS, all sorts of frameworks built on top of that. And the list of dependencies that you're going to need in a typical TypeScript project are often way larger than a typical Python project, because Python just has more things included out of the box. I've had several projects in the past where my node modules folder that contains all the dependencies was over a gigabyte. That said, the added complexity makes sense because the languages have different use cases. Python has extensive libraries for science, AI, and backends, APIs and automation, but a bit less focus on web development. Even though there are frameworks like TypeScript for building data dashboards, for example, or obviously Django. Now, TypeScript, since it compiles to JavaScript, really dominates in web and network applications, both front-end with libraries like React and Vite, and backend with Node.js. TypeScript is really ideal for building complex, scalable web apps and maintaining really large code bases. The type system provides safety at the cost of more verbosity, complexity, and an overall learning curve. And by the way, if you're starting a new project, you want to learn the 7 most important things to consider, check out my free design guide, arjan.codes/design guide. It's a really practical guide that will help you get started quickly. The link is also in the description. Overall, I'd say Python and TypeScript both have their strengths and trade-offs, but like I said at the start of the video, they are actually quite different. Python focuses on things being easy and flexible for the developer, but harder for the user. Developing a Python script is really easy, but deploying it to users is harder. They need to deal with installing the right version of Python, dependencies, etc. TypeScript and JavaScript focuses on things being easy and flexible for the user. You open your browser, type URL, and you're off. It's going to do everything to avoid crashing with an error because that's not a great user experience. However, for developers, it's pretty hard to set up everything. Debug your code, especially if it runs client-side. Make sure it works on a variety of devices, which is a whole can of worms that I haven't even covered in this video. But now I'd like to hear from you. Have you used TypeScript? How do you feel it compares to Python? Do you enjoy having a node modules folder of several gigabytes? Let me know in the comments. You might wonder how TypeScript and Python relate to other languages I've talked about on the channel, like Rust, for example, which sort of combines Python-like readability with TypeScript strict typing, but with more performance and safety. It's great for system-level programming, but it does come with a really steep learning curve. Go, on the other hand, is more closely related to Python, but it's still statically typed like TypeScript. And there are definitely cases where I prefer using it over Python. To learn more about that, check out my full video covering Go. Thanks for watching and see you next time.